Hi, I am Jayati Gumbar from CUE 25, and for my manufacturing processes assignment, the product that I have chosen is this lemon squeezer from my kitchen. Consider a watermelon. Would you want to eat the green stuff in that? No, it's gross. And thus, while manufacturing a product, we would not want the excess material to bother us. So, we have material removal processes. They are a family of shaping operations in which excess material is removed from a starting workpiece, which in our case would be a billet, so that what remains is the desired final geometry. The three principal machining processes are turning, drilling, and milling. So, after the bulk deformation of our billet, facing and turning provides the final geometry and dimensions. In facing process, the tool is fed radially into the rotating work on one end to create a flat surface on the end. In turning, a single point tool removes material from surface of a rotating workpiece. By now, we would have achieved something like this. Now comes the step for forging. Forging is a deformation process in which the workpiece is compressed between two dies with gradual pressure or force. Now, forging can be explained using some home appliances like a manual juicer, like this. When the orange peel is kept here and to extract its juice, and after this we see that the orange peel gets deformed in the shape of the manual juicer. Similarly, a lemon squeezer is an appliance where forging can be explained. Like when we put lemon and we squeeze the lemon using pressure applied by this metal, then we see that the lemon gets deformed in the shape of the lemon squeezer. I'll just show you with the example of this aluminium foil. I'm folding it to create layers because it's very thin. And we place it here. And on applying force, we see that it takes the shape of the lemon squeezer. Like this. Now, after forging, some flash remains. Like this, the extra foil, there is some flash that remains. This has to be trimmed out. We can use impression die forging for our purpose of manufacturing the lemon squeezer, which is performed with dies that contain the inverse of the desired shape of the part. We have achieved this look. Next step is to drill for knockdown fittings. Drilling can be performed on a lathe by feeding the drill into the rotating work along its axis. Now, no one wants to use a heavy tool, right? So to reduce the weight of our tool, we can purposely remove some material from this holding edge. We can use boring, where a single point tool is fed linearly parallel to axis of rotation on inside diameter of an existing hole in the part. We can also use slot milling to do the task where width of the cutter is less than workpiece width, creating a slot in the workpiece. End-end pocket milling can be used too. Here, we can see that various processes can be used for a particular task. We can consider factors like time to do the task, how much a tool gets steered down on usage, and then decide which process we want to continue with. Further, perforating is done, which involves punching of holes in sheet metal to allow passage of fluid, lemon juice in this case. With this, we complete manufacturing a lemon squeezer. Thank you.